So I want to be sure that we label some points here that so we don't forget them as I try to stay on this one blackboard right here. So what do we have here? We have this point right here corresponds to A is equal to 1 and C is equal to 1/4. So I'm just going to write the number 1/4 right here so we can kind of see how that projects down like that. This point was also at A equals 1/4. Okay, that point right there, and that should help us. So the next step, because we want to see what the edge of our area looks like over here. So I'm going to take this plane right here. I'm going to take it and kind of straighten it out and put the B. This is going to be a little bit strange at first for people who don't like flipping axes, but remember here this right here, this line right here is the B is parallel to the B axis, right? And that's what this is right here. So that's meant to be. And this is right here, this is parallel to the A axis right there. And this is at C equals 1, right? Because this is the plane right here. C is equal to 1, and A is between 0 and 1, and B is between 0 and 1. So it does look a little strange that we're going up and we're going to the left, but it's really necessary for us to see how this graph works. And it's going to because as I mentioned before, here we have A and C are kind of symmetric, not symmetric. I mean that's the word, not the right word, but they're in this formula right here. They look almost like they're going to be they're interchangeable, and the graphs are going to look very similar. So at C equals 1, we have, let's go back to this guy right here. We want to know our relation between B and A. Well, B is going to be less than 2 square root of A. And that means B, no, let's just leave it like that. And so first we're going to graph the line B is equal to 2 square root of A, and then we'll deal with the inequality. So how is this going to look? Again, we're graphing to the left, and the left is positive, just because of the way the 3 dimensions work here. Okay, so what about this? Well, at A equals 0, you can see at A equals 0, B is equal to 0, and just like before, we're going to go a little ahead. At A is equal to 1/4, which is right there, let's say. Right, we're taking the square root of 1/4. So we're at A equals 1/4. B is equal to 2 square root of 1/4, which is equal to 2 times a half, which is equal to 1. So we have that point right there. So now we're just going to connect these dots. And I know they form this sort of parabola on its side because you can see this. Here's the kind of the parabola. B squared is less than 4ac. So also at A equals 1, we're going to be up here just like we looked like before. And it's going to look like that, but we are constrained to A, B, and C between 0 and 1. So let me just keep us in that unit square. And where are we shading here? Well, B is less than 2 square root of A, so we're dealing with all of this, and I should do that in red, shouldn't I? Let me change that to red too. So this is what's going to be over here. Now I can't see it that great, but that's what it's meant to be. Okay. So we have our area. So we have our volume. We have our figure. Now the trick is just going to be, how are we going to do this? How are we going to find the volume of that? And we're going to use calculus. But there's a way to visualize this, and then to get it, and I'll kind of maybe set that up, and then over the next few videos, it might take me a few to complete it. But let's do the bigger thing too first. Okay, so finding the volume of this is going to be, that's all we're going to do. How are we going to do it? Let me pick a color. Let's do dark blue. So we really just need to find that's not dark blue. We need to find the volume of this guy, and I just took it away for a second there. And setting up the limits of integration on this is going to be essentially the trick. But to find the volume of this, I want to do one small change, and it's not going to be a huge thing. If we found, when we're talking about it, for a second here, we talk about it, A equals 1 and C equals 1. You can see it right here. B, so A, C equals 1, 1. B is equal to, well, it's not equal to, it's really less than 2. All right, that was a point when I took these planes off the side here as a point. So we're looking at this point up here, kind of out in space, and this is just over the point 1. This is over A, C is equal to 1, 1. So I'm going to connect that. I'm going to continue this space up like that. And it wasn't very smooth there, but it would just, so it would go up there, and this piece up here would come like that. Okay, so we really want the volume of the blue space. Well, it's no small leap that if I found the volume of the whole thing, if I found the volume of this, I should do the different color. Let's do the volume of the whole thing. Right, that's with the top, and I subtract it off the top part. I would get, so let me just do that right there. I subtract it off that part. I would be left with the volume of the space we're looking at. Now you don't have to do it this way. You could find the volume of just this piece a very straightforward way and set up the limits of integration. There's just a few more limits you have to deal with when you do that, and I really like it this way because it's we can kind of see the picture. We can see the picture developing and a little bit easier. Okay, well, I am going to do that again, like I said, over the next few videos. I don't know how much time I have left, so I'm going to stop.